Dr. Sorrell for that very good introduction. So today I will be discussing my thesis work entitled The Effects of the Alanine 2-Valine Mutation of Human Cardiac Troponin I on Myofibril Regulation. So this mutation lies in the unique N-terminal extension of cardiac TNI and has been linked to dilated cardiomyopathy, as Dr. Sorrell alluded. Before I begin discussing my experiments, I would like to just provide a brief introduction to the thin filament proteins and to the regulation of muscle contraction. The fundamental contractile unit of the cardiomyocyte is the sarcomere, shown here, which is made up of overlapping assembled thin filaments containing actin and thick filaments containing myosin. The regulated interaction of the myosin with the actin causes the thin filaments to slide over the thick filaments such that the sarcomere shortens or contracts. In more detail, the thin filament is actually composed of several interacting proteins, including actin, depicted here as the gray spheres, the flexible coiled protein tropomyosin, shown in orange, which winds around actin, and also troponin, which actually consists of three subunits: cardiac TNC, shown in red, which binds calcium; cardiac troponin I, shown in green, which inhibits actomyosin ATPase; and cardiac TNT, shown in blue, which anchors this whole troponin complex to the tropomyosin actin backbone. So the dynamic interactions among these thin filament proteins serve to regulate the interaction of this myosin with actin and therefore regulate muscle contraction. In the resting state, shown in this upper panel, intracellular calcium levels are low, such that no calcium is bound to the regulatory site of cardiac TNC. In this state, the troponin complex exists in a conformation in which the cardiac TNI inhibitory regions and mobile domains are bound to actin and inhibit this myosin-actin interaction. In addition, the TNT holds tropomyosin in a position that blocks the myosin binding site. So again, in the absence of calcium, the interaction of myosin and actin is inhibited. On the other hand, during systole, shown in this bottom panel, the intracellular calcium levels rise, and the binding of calcium to TNC causes a rearrangement of the troponin complex, such that the switch region of cardiac TNI now becomes bound to the end lobe of TNC and results in the inhibitory region and mobile domains pulling away from actin and alleviating their inhibitory influence. In addition, I would also like to note that in this state, the cardiac N-terminal extension also interacts with the end lobe of TNC. However, its role is less well documented, and I will actually be discussing it in further detail in a few slides. In addition, the overall structural rearrangements of the troponin complex leads to the movement of tropomyosin along the actin thin filament, exposing the myosin binding sites. So the interaction of myosin with actin results in the splitting of ATP and subsequent force generation.